welcome to my third video. In this video, I'm going to explain about rest and motion, and we strictly confine the motion in straight line. So let's get going. So first of all, we will learn about what's called rest. So here you can see that there is a car, and the car is uh, standing, and there is another object, there is a tiger, and as the time is going on, you can see the distance between the tiger and the car is not changing. That means with respect to the tiger, the car is at rest, and with respect to the car, the tiger is at rest. Alright. So we will say that if anybody does not change its position with respect to any other object in surrounding, then it's said to be at rest. Next, here comes motion. So here also we will see that as the car is moving from this object, that is that each and every time the position of this car with respect to the object was changing, and therefore we can say that the object was in motion. Next comes your types of motion. So here mainly basically there are three types of motion exist: motion with constant velocity, zero acceleration. That's we call uniform motion, and the motion with constant acceleration, and the motion with variable acceleration. The third category falls into the day-to-day life experience. We see different types of motion: the bike, the car, the flight, the train, etc. all around us. Those motions fall in the third category. All right. So uniform motion. So if we take an example of a car which is moving, you can see, and if we just take a plot of its position and time, you can see after every equal time interval, the position is changing equally. That means it's uniform motion. So you can see in the first 2 seconds, the position changes by 2 meter. The second 2 seconds, the position changes by 2 meter, etc. like this. So in uniform motion, what happens? The position changes equally with respect to time. Non-uniform motion. So here also we take an example of a moving car, and as the car moves, if we take the history of position and time, then we'll get something like this. So here you can see that the position is changing not equally, right? So this type of motion is called non-uniform motion. Now let's define speed and velocity, very important factors. And they actually define as speed is defined as the rate of change of distance travel, or is distance travel divided by time taken, and velocity defined as the change of displacement with respect to time taken. Generally, the distance travel is more than or equal to the displacement. So the speed is either more than or equal to the magnitude of velocity. Why we say the magnitude of velocity? Because velocity is a vector quantity. Now the vectors that we study in the upcoming time, but for now, each vector quantity has magnitude as well as direction. So here we have to consider the magnitude of the velocity. All right. Next, the first example of a moving of a man. The man is moving and its time position values are shown here. This is the example of uniform motion again. So here you see, if you take the interval from 0 to 12 seconds, in this interval, the body was constrained to move in a given direction. So its distance and displacement were same, and hence its speed and velocity. Next, example 2, we see ball is moving and coming back. Yeah. So its position and time is shown in the figure like this. So here if we calculate the distance traveled by the body in the 12 seconds is 10 meters. So 12 minus 10, 2, 2, 4, 2, 6, 2, 8, and then 10. So its and the displacement is 6 meter. So speed is 0.867 and velocity 0.5. So here from this example, from earlier example we have seen the speed and velocity is same, but for this example we have seen that the velocity is less than the speed. Okay. Next, equation-based study of motion in straight line. First of all, uniform motion. In the uniform motion, what happens? Suppose a body is moving in a given direction in a given time interval, and its distance travel is x. Therefore, the main equation and the foremost one equation, that is v is equal to x by 8, is the main equation. We can also write x equal to vt. So, based on these two equations, we can study entirely the uniform motion. Here also again we have to define speed and velocity. So first of all we define speed and velocity mainly are two types: uniform and non-uniform. Further, these two can be subdivided as average and instantaneous. Now, what is average in velocity? That is calculated over a time interval. If we say that what is the velocity from 9 am to 11 am, that's the average. And if we say what was the velocity at 12:30 p.m., it was instantaneous. All right. So you can see that there's a road and the car is moving on the road. So this is an example here. The car was moving for 0 to t second. Okay, in between this 0 to 2 second, t second, we take any of the interval t1 to t2 seconds. So in that time t1 second, its position was x1, and time t2 second, position was x2. If you want to calculate the speed and velocity here, you can see the average speed and velocity over this time interval from t1 to t2 second is x2 minus x1 by t2 minus 2, delta x by delta t. So since the car was moving in a given direction in the interval t2 second, therefore average velocity, average speed is same. And if we want to find the instantaneous velocity, we will get like this. Here, this is called qt, which I have already explained in my second video. And dx by dt, this is the instantaneous velocity. That means velocity is a particular interval of time. Right. Next come motion with constant acceleration. So this is the example of motion with constant acceleration, time and position values. So here we first know what are the acceleration. The acceleration basically is the rate of change of velocity. And acceleration in motion can cause due to three factors. First of all, change in the uh, magnitude of velocity, that means the accelerated motion in one dimension. Then due to the change in the direction of motion of the velocity, the uniform circular motion, or due to both, that is magnitude as well as direction of change in the velocity, that means non-uniform circular motion. So here you can see the velocity is continuously increasing. All right, that means here the acceleration is constant, and if you calculate the acceleration turned out to be 0.25 meter per second square. So acceleration further can be divided into two categories like average, uniform and non-uniform acceleration, and that can be calculated in two ways. Either average, that is calculated over a time interval, and instantaneous, that is calculated a particular instant. So again we see the car is moving, right? So here we have considered that at time t1 the velocity was v1 and time t2 the velocity v2. Obviously v2 is greater than v1. Say then the average acceleration is v2 minus v1 by t2 minus t1, that is delta by delta t, and instantaneous acceleration is instantaneous limit delta v by delta t, that is dv by dt. So this is very important. Acceleration, velocity, all these factors are very important to study the motion primarily, right? So the equations mainly used for study uniformly accelerated motion, as you can see, the object is moving. Suppose we consider the time interval of any time. Here this second, we consider the initial velocity u and final velocity v at a particular interval of time, and s was the distance covered. Then we can just use these equations to find the final velocity, the acceleration, the distance covered by this equation, and this equation also a useful equation, right? So uh, basically, this is the basics of motion in a straight line, or you know uh, rectilinear motion with constant acceleration. And earlier we have seen with the constant velocity. After that, when you go into the entrance level, we got some more and more equations. For that, you have to wait and coming in the after videos. So, by the way, thank you all for watching.